Hello class, this is the second and final lecture on probability that I'm going to give you in our short overview. Again, I really encourage you to take statistics and learn more about real life. It's a very meaningful and useful way of describing reality that mathematicians have found in the language of probability. I'm going to teach you something today that doesn't feel like it has anything to do with probability at all. It will be quite surprising to you that this is also probability, and I'm not going to explain the connection about probability. That'll be the worksheet that you do. So this is just going to look like pure algebra of just manipulating symbols, and you'll find out why it is probability on class day. So let's talk about what we're going to do. What we're going to do, it's called the binomial theorem, and it is a description about what happens when you put a binomial to a power. So binomials that you might have seen of like x plus 3 or x plus 1, and then we're going to raise them to some power, like 2 or 3 or 10 or 1,000. So what happens when we do that? What happens? Well, let's start off with the basic stuff. Let's talk about x plus 1 to the 0. Well, that's dumb. That's just 1. All right, so then what about x plus 1 to the 1? Well, that's just x and 1. That's just itself. Anything to the 1 is itself. All right, and then what happens when we square it? When we square it, we get x squared plus 2x plus 1. You've seen that before. That's not too dramatic. And now the math starts getting a lot harder, and maybe things you haven't seen a lot of. If I try to say, and I said 1. It happens if I say that cubed, I could take that one over there and then multiply it by x plus 1 again. And long story short, I'll spare you, is that you get x cubed plus 3x squared plus 3x plus 1. Okay, where is this going? Well, if I do it again, the numbers start to get pretty much out of control, you would think. But I can do them, because I know the secret, without having to multiply at all. That I can tell you that that's going to be x to the 4th plus 4x cubed plus 6x squared plus 4x plus 1. How can I do that? How am I able to predict what that's going to be without having to do a whole ton of math? Well, I'll tell you how I am cheating. There is a famous example of this called Pascal's triangle, and it's actually much older than that. We have written documentation of it being done 1,000 years beforehand in China. But Pascal gets the credit. And what it is said to be is that you take the numbers that are above any given number you're looking for in this triangle. So above the 2 is this 1 and this 1, and you add them together, and that gets you the next number. So on the outside, there's nothing to add over here, so these guys get together and make there's a 0 over there, On the outside, it's like there's just zeros all around, and so then 0 and 1 make 1, 1 and 2 make 3, 2 and 1 make 3, 1 and 0 make 1. So that's the next level there. And then you just keep adding, and all along the outside, you're going to have 1s, and you just keep adding them down. So 1, 4, 6, 4, 1 is the one I just did. The 5th level of the pyramid is going to be 1, 5, 10, 10, 5, 1. The 6th level of the pyramid will be 1, 6, 15, 20, 15, 6, 1. On and on and on like that. So I think you get the idea about how the pattern works. And this describes what happens when you apply powers to a polynomial, whatever the polynomial is. So the way mathematicians like to talk about that is they say, okay, so our polynomial could be made out of anything. It's a plus b, and we're going to raise it to the nth power. So this is going to be an alphabet soup, so brace yourself. Let's keep track of, so a is the first term. Let's have a little translation guide off to the side here. B is the second term of our, together, those are our binomial. And then n is the power. And then we're going to find, now this is going to get weird, the kth term, and k starts off at 0. What do I mean by that? So if you look back up here, that this x to the fourth, it made 5 terms. And so then this one would be the 0th, the first, the second, the third, and the fourth. So there are 5 terms, but because it's math, and it actually, you'll appreciate this. You think I'm crazy for starting off at 0, but it makes the math way easier if we start off at 0, the 0th term. So k is the term number minus 1. Okay? So how do we do that then? Well, it turns out that if we want to find the kth term of a plus b to the n, it is equal to n choose k, a to the n minus k, b to the k. All right, let's highlight that and bask in its awesomeness for just a moment. All right, what does that even mean? N choose k. What is that? Well, that turns out that this is the first hint about why this is in a probability section. That is n combination k, like that. Okay, so that's what that 2 numbers on top of each other in parentheses means. So let's do one here. Let's come down and let's make this specific. If I have 2 to the 2x squared plus 3 to the 4th. Okay? So let's think about that. Well, the first term is really obvious. We could be able to get that without needing to know the binomial theorem. We would know that the first term is 2x squared times 2x squared times 2x squared times 2x squared. So let's see if the math backs us up there. So we're saying that this is the four things taken 0 at a time, order doesn't matter, of 2x squared, that's a, to the 4 minus 1 times 3 to the 0. Okay, so that, do you see how all the little bits and pieces lined up there? That this, let me see if I can color code it for you. That this is A in there, and then this is B right there, and then K is the term that we're on, so that's the zeros there, there, and there, and then the power that we're applying is 4, so that's there and there. Okay, so that's just to find the first term. The way we want to find the first term is we have 4 things taken 0 at a time, order doesn't matter. So that's going to be 4 factorial over 4 minus 0 factorial, 0 factorial. Well, that's all going to cancel. And then 2x squared to the 4th. Do not be fooled. Do not think that this is just 2x to the 8th, that you have to, the 4 exponent has to land on both of those guys. So 2 to the 4th is 16, x to the 8th, and anything to the 0 is 1. Okay, so there's the first term. The second term is going to be 4 choose 1 of 2x squared to the 4 minus 1, 3 to the 1. Okay, so 4 choose 1 means 4 factorial over 3 factorial, 1 factorial, and all that to the third is 8x6 times 3. All right, so 4 factorial over 3 factorial is just 4. 4 times 8 is 32. 32 times 3 is 96. So 96x squared I have the polished version down here. Okay, next term is going to be 4 choose 2 of 2x squared to the 4 minus 2 times 3 squared. 4 choose 2 is going to be 4 factorial over 2 factorial, 2 factorial. And that term, the next term squared is 4x to the 4th. And 3 squared is 9. And so then that is 4 factorial is 4 times, that's 4 times 3 over 2 times 2. So that's 3. 3 times 9 is 27. Times 4 is 216. Okay, so that's 216x to the 4th. All right, so you can see how this can keep going and going, and that we can expand anything. This allows us to find any given term of any given expansion that we want. So any binomial, no matter how scary, we can find a particular term in it. All right, so last example then, and I'm done, is that someone might say, find the fourth term of square root x minus 2y to the 5th. So what we're doing is our k is not going to be 4, our k is going to be 3, because it's always one less than that. The k's start with 0, the terms start with the first. So this is, we're going to have k equals 3, n equals 5, a equals root x, and I think it would probably be easier, since we're going to be dealing with exponents, if we called that x to the 1/2. And then b is equal to negative 2y. Okay, so we put this into the formula, and we say that we've got n choose k times x to the 1/2 to the 5 minus 3 and negative 2y to the 3. Okay, so 5 choose 3 is 5 factorial over 2 factorial, 3 factorial. And 5 minus 3 is 2. 1/2 exponent to the 2 is just x. And then negative 2 times negative 2 times negative 2 is negative 8. And then y times y times y, like that. All right, so what is 5 factorial? It's 5, 4, 3 factorial, which will cancel with that 3 factorial, and a 2. And so that's 2, so that's 10. Okay, so 10 times negative 8 is negative 80xy cubed. So rather than having to expand that whole possibility of all those different terms and get the huge x to the 5th equation, we can just find the 4th term in the list, jump to it with the binomial theorem. What does this have to do with probability? You will find out when you do the worksheet in class. See you soon.